So today we'll talk about inheritance properties. Okay. So, okay, what is inheritance? Any idea? So inheritance is situation where one member, okay, or one class is extending another class. Okay, one class is extending another class. Okay, so let me give you an example here. Okay, so let's say you have a class here. Okay, the school, and then you have another class here. They are different class. Okay, they are different. It doesn't matter, what value class has, what value. Let's say this is school and this is student. Let's say school and student. But what we want is there is some properties here. There is one method
Sir,
here. Yes.
sir, we're not able to see the anything. The pie chart is visible.
Okay. I'm sorry. Wait 1 second. I'm sorry. Can you see it now?
Yes, sir.
Sorry, yeah, it was not shared. So I was saying that we have a class called school here, and we have another class called student here. Okay, they are different class, but there's some proper because since it's a school and student also belongs to same school. Let's say this student also belongs to same school. There will be something which is common in school, right? So if it is common in school and if it is common in student, it doesn't make sense to duplicate stuff. I told you, first thing that you have to do in good design, when you talk about design of programming, okay, or application or software, whichever language you are using, data science, machine learning, or simple programming or database, okay, the first thing that we have to take care of is duplication. There should not be any duplicate. What happens with duplicate? We know, right? Duplicate, now let's say if you have to change at multiple places. You don't know if data is at sync or not. Let's say for reading it is important. Let's say you have you have a telephone directory. These days we don't need telephone directory, but let's say you have a telephone directory, right? And you have, let's say, big house, you have 10 rooms. Sometimes you'll be in this room, sometimes in study room, sometimes bedroom, sometimes in drawing hall, kitchen, right? So you need to make calls. So so if you have only one copy, you'll put it in one place, and now you have to search where it is. So what do? You take a copy and you put it in 10 different places so that it is always accessible. This is good when you are doing reading. This is good when you are doing data analysis. But in practical sense, this becomes very messy because numbers will get changed. You have to add more. Now to add, you have to add in all the 10 different copies. And if you miss to add even in one, the data becomes outdated. So maintenance of data is very difficult if you have duplicate values, right? You have to update everywhere. You have to make sure that it's all in the same sync. Somewhere you might put spelling separately, differently. You'll have different spelling in different place. Okay, it becomes mess. So that's why we say that we should always have one copy. Do not create multiple copies. Now here there's a method which is common for both school and student. If it is common, why can't we make student read this method from school directly? Why should we have it separate? Okay, so this is called inheritance. Inheritance, you have base class. Okay, so you have base class where you have the data. Okay, so since school has the data, school is not bothered about student or anybody else, right? Okay, from the class perspective I'm talking about. But let's say you have student, you're creating another student. So what you can do is you can say student as a derived class of base class. Okay, so when you have one class which is deriving the members of another class, we call it inheritance. Okay, and we have different types of inheritance. This is simple inheritance. Okay, one class deriving data from this. Now you can have one more class called staff or teacher, right? Teacher will also derive here. So in this case, you have two derived classes and only one base class. You can have one more base class here, and you can link this here. Okay, you can link it or you don't want to link it. Let's say you have staff something. Okay, staff can be teaching and non-teaching. Okay, so non-teaching staff is class is here. Okay, so it can have any kind of extension. Okay, it becomes complex inheritance. Okay, we say multi-class, multi-level, this is multi-class. Okay, same level you have multiple derived and multiple base class. If you have one more, you can have one more class here. So this is called multi-level. You have one level and second level. Okay, so it doesn't matter whether it's multi-class or single class or multi-class or multi-level, the properties would remain same. Okay, the way you access is remain same. And I always like to give this example here, right? So let's say, your base class is like your parent class. Okay, it's like parent. Base class is like parent, and derived class is like child. Okay, so children has access to the parent's data. Okay, but parent will not have access to children's data. Okay, so this is the fundamental, this thing that your so if you have something here, this is parent class, right? So you will have access, student will have access. Let's say your father has a car. Okay, you can borrow your parent's car, but when you have a car, your parent cannot borrow it. Reverse inheritance is not permitted. Okay, and that is the property of inheritance, that you don't have to duplicate. Now let's say if your father already has a car, why do you have to have a car, right? So you don't need to. Okay, but you can. If it is different, you don't want to drive that car, you want to have different car, so you can always buy another car, right? But the property is that you have the access to this. Okay, so this is simple concept, that's it. Okay, now we'll see how to implement this, right? So we talked about base class, and base class will not have a reference to the child class. Now, if you look at your as a parent, if you see your ID card, right, driving license or any card, if you have, you don't write your children's name there, right? But children will have linkage to the father. That's how the link is established. Children will have father's name in the passport, right? But you will not have your children's name in the passport. So from base to derived, there is no linkage. That's why you can't claim that, I can use this method. But children will have their parents' name on their passport. So children can claim about parents' properties. Make sense? So now let's see. We'll derive first we'll create our base class. Let me stop sharing. That's what I was trying to see. Okay, so let me create a base class, right? So I'm going to create base class called as, let's say, school. Okay, and we'll add some property to school, like school name, right? So we say class school, right? And your first method that you put in class is def init, right? Init is used to initialize variables, correct? Okay, so now let's say here we'll have initialization like school name. So I'll say self dot school name. Okay, now it has to come from school name, and which will be passed here, right? School name. Okay, perfect. Okay, so let's have only one variable now, and later we can add more to it. Now we give a property called def, okay, display details. Okay, we call it display details, right? And I'm going to say print school name is, okay, and you say self dot school name, right? Okay, so this is your class school. Now we'll talk about another class, okay? Class student. Okay, class student. Okay, and then I'll add some method to it. Let's say we'll add def underscore init underscore. Okay, we'll add name, student name, st name, student name, and I'm going to say self dot st name equal to st name, right? Fine. Now I put another class. I'll put another function called def. Okay, display. Yeah, I'll copy and paste. Okay, same stuff. There's no chance of making mistake in spelling. And I'm going to say print student name is, and you say self dot st name. Perfect. Now these two are two different classes. There's no linkage between them, right? I can create school. I'll say sc1 equal to school and equal to school, right? And I need to pass the school name. So I'll say ABC International. Okay, and you can display, create a student name equal to student. Okay, and you say Sachin Tendulkar, right? Tendulkar. Okay, now I can say sc1 dot display details, right? So it will display details of the school, and then I say st1 dot display details here. Okay, so both have same function, but it is different, right? Obviously, class 1 has different intention for display details and has different one, right? So you get it right. Now, I want to make student derived of class school, right? So how to make it derived? So as I said, you don't have to give anything in school. You don't have to link backward, okay? You don't have to link to the child, to the derived one. But derived should have link, right? You always have your parent's name in your documents, not your children's name, right? So parent name. I'll say student belongs to school. Okay, I'll say student belongs to school. Now you see it became a derived class of school. School is base class and this is a derived class. Okay, you can have one more class, let's say a teacher, right? So you say teacher here. Okay, and I'll say T name, teacher name, right? T name, and you say T name. Okay, so I can create teacher. So I'll say T1 and I say teacher and you say Kapildev, let's say. Okay, now you can say st1. So okay, so we have derived teacher and student both, but in a way we are not making them use anything, right? If your program is just like this, then there's no point of making it derived. Okay, there's no point of making it derived, right? Now let's say, okay, I do not have display details here. I make it 1, display details 1 in student. So I have named it differently, but I'm calling it display details, right? So what happens since, okay, so school 1 will call display details directly. Okay, for school 1, there's no confusion, right? School has school, display details, and I'm calling display details of school. So this will display the school name, right? That's fine. But when you call student.display details, it will go and check in the student class. Okay, it will not find, it's not there here, right? If it is not there, then it will go and look in all the linkage here. So if you have T here, teacher, right? And if you call a function or method which is not there here, it will search in this also, it will search in this also. Okay, it will go and look upward. And how do you, let's say if you have to link teacher to both student, let's say student is also base class, you'll say school comma student. Now if you have to draw this diagram, you have a school, then you have student and you have teacher, right? You have to draw this diagram. It will look something like this. You have school here on the top, then you have student here, Then you have teacher here. Teacher is derived class of student as well as derived class of this. It will look something like this. But for this case, we don't want to do it, so I'll remove student. Okay. So in case of student, okay, it is looking for display details. It did not find here. So then it will go and check into the school class, the base class. And now you see here, 1 second. Okay. What happened? Okay, object has no school name. Okay, so did we not give school name? Yes. Okay. Okay, now you see here school name. So what is happening is display detail is taking it to where? Taking it to display details here, parent display details. Correct? Parent display details uses school name. Right? So school name is object level, and school name will be created only for school name will be created only for school, right? Now we are not creating object for school. Since we are not creating object for school, this init is not called, and the school name is not given here, right? So in such case, you have to give school.init here only. Okay, in this init, this is a student init, right? So I'm going to say school, the class name dot init, and this is where I need to give, okay, the school name. So first self, and then you give the school name. Okay, now from where the school name will come? School name should come from here, right? So I need to give school name here. And now when you create the object of student, we need to give two more values, Sachin Tendulkar and the school name, which is say XYZ International School. Okay, now when you run it, it will print XYZ, school name is XYZ International. Now the language did not change, it is school name, because the display detail it's taking is from the parent class, from the school class. Okay, and we are passing the init from this one. Right? And if we did not had this school name here, then we could have directly printed this value, display details. So in this case, if your intention is to print school name is, then there's no point of creating a duplicate copy. Use same one. Yes, it needs school name, so you pass it like this. So in it will take two parameter, and then you call the school name in it, and then rest of the things are taken care of. Yes, question. Avi, you had a question?
No, sir, clear.
Okay. Okay, so this is your inheritance. Simple. Okay, if you understand, just couple of things. One, you need to decide, okay, which class will be derived and which will be base class. Okay, and see, this same concept presented in different manner, it will result into other terms like encapsulation, polymorphism. All these are derived from this. Base is inheritance only. Okay, now we talk about encapsulation, polymorphism. We'll talk about it, if not today, tomorrow. If you get time, we'll talk about today itself. But forget about those things. Look at this. So you have some method here. You want to display school name. If you want to display school name, then why do you have to create? You can do it here also, right? You can say school name is, right? I can, take this and put it here. Okay, so you get school name, but that's what is the basic purpose is to avoid duplicating of code. Why do you want to duplicate the code? If your school name is already here, right? Why not use it? Why do you have to have your own? Do not have your own, use this one. And this is how, for a user, okay, see, this is implementation details, right? All these are hidden from the user. This is your engine, how the engines are put in the car, right? All the connections and all those things. For a driver, they just need to know this. Now, for me, if you see, or for the user who has not developed this class, will not know that you are printing XYZ from parent class. Okay, there's no way to know. And that's called implementation hiding. You're hiding the implementation. You don't As you don't know which class has which method. I want to do this, so I have it. Okay, did you get it? Now, when I say teacher dot display details, teacher has its own display details. Okay, right? So yeah, teacher name is right. We'll put teacher name, and then you need to T name, right? So T name. So now, if you want to display details of teacher, teacher will not go to the parent. It doesn't make sense to go to parent because this is different. This is teacher name, not school name. If it had been school name, then you should go to parent and get that method executed. Okay, so code reusability, write once, use multiple times. Even if there's a slight difference, you'll have your own, then it's fine. Okay, but if there is no difference, not even slight difference, then why to create a 2-copy? Okay, now what is encapsulation? Encapsulation means hiding it from your different class, right? Now, encapsulation talks about access modifiers, and we have 3 types of access modifiers. We discussed this, right? Public, protected, private, right? So private is marked with double underscore variable name, okay, double underscore, okay. This is your private. Single underscore is protected. Single underscore. Protected variables are marked like this. And public is what we have been using. All these are public, okay? No underscores. Now, let's say for some reason, I want to make display details private. Double underscore. Okay. Now, okay. Oh, did I put this one here? Okay, I need to remove it, right? Remove it. Because I want to use the previous one. Now, when you run it here, you get error. School object has no attribute display details. Okay, why? Okay, because it is double underscore, right? We mean double underscore, correct? Double underscore. Even double underscore, now you run it. It says school attribute has no attribute double underscore details, but it has, isn't it? Right? It's saying because double underscore means private, and private cannot be used outside the class. You cannot use outside the class anywhere. Within the class, you can use it. Another method can call it, but no, you cannot call here. So that's why it says not available, because we have declared it as private. Now, if you make it protected, okay, if you make it protected, now when you say sc dot, okay, now when you create object name dot, it will give you the list of methods, right? You see, display details is not there. So protected can be called by another class, but cannot be called in the main program. That's the actual meaning of protected. Protected means the variables are the functions, okay? The variables are the functions that you declare as protected can be called by the derived class. Derived class can call it. So student can call it, but teacher cannot call it. Main, we cannot call it. Okay. So see, we are not getting that thing only. Underscore, but in Python, we said that it is not strictly, strictly implemented. So even though it's not able to display, but when you call it, it will be called. Okay. It will not give error. Protected will not give error. Has no attribute display details. So this is coming from student, right? Student is underscore, single underscore. Okay, so protected concept wise it is there. That's why when you say dot, we could not see the underscore. Concept wise it is there, but practically you don't have it. Okay, practically, sorry, concept wise it is there. Practically that is not enforced. Okay, so protected works very much or exactly like your public. Okay, and you see that private cannot be accessed. So that's how you can control the display or accessibility of your members. Okay, so we did inheritance and encapsulation. So there's one example in the book. Okay, I don't know the page number. Um, let me just see. Give me 1 second. Okay, yes. There's one example here. You have point and set point shape. Can you practice this by today? So what we have created point, which is main class, and then we have shape and rectangle, which are using the properties of parent class. Okay, and I will put it in the notes also, so you have the program there. So practice that. With that, we finish inheritance, and tomorrow we'll talk about polymorphism. Same example. Okay, what does polymorphism means? See, polymorphism means poly means many, right? And form, morphism means forms, many forms. So here also we have many forms of display details. Okay, you can create multiple display details. Okay, but based on what you need to use, it knows. Okay, and definitely here in Python you do not have, okay, in C++, Java, you also have concept of polymorphism, where the values will differ on the number of elements that you give. Okay, now in this is not true in Python does not implement that. But in Java, what happens, you can create let's say display details, right? You can create display details 1, you can create display details 2 and 3, right? Same this thing, sorry, same this thing, but what it does is, once you might have like 1 parameter, and once you might have 2 parameter. So if you call display details with no parameter, this is called. If you call display details with 1 parameter, this will be called. If you call display details with 2 parameters, this will be called. Okay, so within same class, you have methods with different names. Sorry, same name, but different signature, we call it. Different signature, same name. But Python does not do that. If you create something like this, the last one will be called, these two are ignored. Okay, so that's why we don't talk about. So there's not much thing in polymorphism here, but yes, the concept is there, and there are a few things that we will talk about it when we talk about polymorphism. But this can be implemented in Java and C++, where you are differentiating the functions or methods based on the parameters. Okay, but in this case, in Python, if you give something like this, only the last one will be taken. So if I call display details with just name, it will give me error that looking for 2 required person argument. Okay, so if I say display details 1 here, okay, and if I run it 1, and if I run it, no, this is comma is not there, right? So if I run this, you'll get error saying missing 2 required person argument, because the last one is being read. Okay, above 2 it is not read. Okay, so Python does not allow this kind of polymorphism. Polymorphism is available only when you have parent and child. So parent can also have, child can also have. So the first preference is given to the child or derived class method. If they do not have, then it will go and look in the parent. Parent might have multiple parent, so it will go and check in every parent. Wherever it is there, it will call. Okay, that kind of polymorphism is there, not like signature. Sometimes you do based on the data type also. So you might have 2, but one is both string, one is both integer. So if you give integer value, it will go to integer. If you do string, it will go to string. That is also not there in Python, right? Python is very simple. Did you understand? So very simple, where basically it means that your method can be in derived class or base class. If you're calling derived class, a method is there, it will not go and like look up. Okay, it will look in the same class. If it doesn't have, then it will go up and look at it. Okay, any question here before we wrap up? Sure. Shall we end it here today?